Okay, I want to welcome everyone to our first webinar in a series of 3 covering testing for Ethernet service activation. Today we'll cover an overview of Y.1564, RFC 2544, and the J-Quick check test. Our next webinar will cover the J-Proof Ethernet forwarding test, and the final webinar is July 12th. At that time, we'll be covering RFC 6349 TCP throughput test. Please join us for all 3. I'd like to introduce our co-presenters today. Michael Bangert is Product Line Manager for Metro Products at Viavi, and Barry Constantine is the Principal Member of Viavi Technical Staff. We're going to go ahead and get started. Mike, take it away.
Thank you, Mary. So let's just talk about the agenda for our webinar today. First of all, what we're going to do is talk about carrier Ethernet services and the SLAs, service level agreements, and KPIs, key performance objectives, that define those services and what the expectations from the customer are on their Ethernet service provider. Then we'll talk about Y.1564 and RFC 2544, which are the 2 primary test methodologies used to test carrier Ethernet services for the SLAs and KPIs at layer 2 or layer 3 level. We'll discuss where to test in a network and exactly what some of the test methodologies and strategies might be. We'll do a demo of Y.1564 so you can get a sense of how that test works. A lot of folks probably are doing 2544 today, so moving to 1564 might be something that you're interested in doing. And then we'll talk about a test that we call Quick Check and some of its uses for what we will refer to as non-SLA services. So we'll talk about what those might be and what might be use cases there. We'll show you a demo of Quick Check, and then we'll finish up with sharing some additional resources and questions and answers. So with that, let's jump into a description of business class Ethernet services and how we define what they are. So the main definitions for business class Ethernet services that are really offered from operators and service providers to business customers is really driven by the Metro Ethernet Forum. They are, or you might refer to them as the MEF. So they're a standards body that has done a lot of work on attempting to standardize the different types of services, really so there's a good agreement between service providers and their customers, as well as between service providers on understanding what a service is, what defines it, how to provision it, and also how to test it. So the different types of services are really grouped into two different bins: the retail services and then the wholesale services. Retail services are services that are offered from a service provider directly to a business customer. The wholesale services are scenarios where the one carrier operates actually has the relationship with the customer, but they rely on other providers for part of that service. So let's just talk about some of these different services that are available and have been defined by the Metro Ethernet service. So the simplest type of service is the E-line service. This is really a point-to-point style service where we've got two locations that we need to provide connectivity between. We'll have a single user network interface that's a UNI at either end of the link, and we'll just transport the traffic from one end of the link to the other end of the link, and every packet that comes in will hopefully get transmitted as long as it's part of the service level agreement. There's really 2 different kinds, and really for all of these services there are 2 different kinds. There's the virtual private line EPL and virtual private line EVPL, which is a scenario where you might have a VLAN tag or not have a VLAN tag. One is port-based, the other is VLAN-based. So this is the simplest version of a service called the E-line service. The ELAN service is a scenario where we have multiple different business locations in this particular example that are all connected through a multi-point to multi-point network. So every business location can communicate equally well with every other business location. So we actually have to make sure that that all of the traffic is flowing to the appropriate location based on the parameters that are in the traffic and what's been defined. So the different flavors of this are layer 2 VPNs, transparent LANs, and multicast network type scenarios. In an E-tree type scenario, this is a place, a service where we have the same types of scenario where we have multiple different locations, but we want to be able to have a root node that will be able to communicate with all of the different branch locations. Think of this as like a head office that then trunks back all of the traffic from each of the branch offices. So the branch offices really need to communicate. If they want to communicate with each other, it's through that head node. So these are scenarios where you see if you have a multi-tenant type scenario, it's a scenario that you might see. You might apply an E-tree type service to that type of offering. So those are the three retail services that are offered: the E-line, the E-LAN, and the E-tree. On a wholesale service type, this is a scenario where the carrier Ethernet service provider on the left is really the one that owns the relationship with the business customer, but they are going to contract out to another Ethernet service provider who is going to handle the access. So this might be a scenario where if you have a service provider who doesn't have assets in a particular region and they want to be able to you contract out with a service provider that does have assets in the region, they would be able to offer an e-access service to that particular business location. And then the scenario here is that you'd have again, from the end user's perspective or the business user's perspective, it might be a E-line type service, but it's actually being fulfilled by an e-access provider that's using an ENI external network-to-network interface to talk to the actual service provider who is providing the service end-to-end. So some of the problems that might roll into this scenario is that you've got two different service providers in the mix. So you've got two different service level agreements that you've got to make sure are guaranteed. And finally, one of the even more complicated scenarios, as this particular graphic shows, is the e-transit service, which is again can be done with a point-to-point EVC from the end customer's perspective, but in this case we've got the carrier Ethernet service provider on the left-hand side who owns the end relationship. They've got an access provider on the right who has the local connectivity, but they actually need to contract out with a transit provider to connect the two together. So that's an e-transit service that is set up in the middle part of this network. So again, now you've got three different service providers in the mix, and potentially three different SLAs that have to negotiate and test. So let's just give an example of a service level agreement that we might want on a very simple point-to-point type network. We've got again, this is a point-to-point EVC type network that we're talking about here with a uni on either end, and we're going to say, well, what's the expectation that the end user should have about this service? And you could say, really, the SLA is what's defined here at the bottom of the slide in the chart. So you've got a committed information rate, or CIR, which is really talking about the bandwidth that we're going to be transmitting through the network. We've got the committed burst size, or CBS, which is really talking about how much can we burst, how many packets bytes of packets can we burst at line rate and maintain our CIR, so we can expect all of those packets to get through the network. CIR and CBS are really the two things that drive the so-called bandwidth profile that the MEF is defined. We've got a one-way delay service level agreement or service profile attribute that we've added here. So we're going to say that the one-way delay should be less than 25 milliseconds for packets to enter on one end of the network and exit on the other end of the network. So that'd be a 50 millisecond two-way delay if we're going to look at it round trip. And then the packet jitter, which is really talking about the differential latency on each packet that gets sent. So we're defining that as less than 1.5 milliseconds here. We've got our frame loss ratio of 10 to the minus sixth. We might want to have a mean time to repair, or MTTR, of less than 3 hours for the service, and an availability that's 99.999%. 5 nines of availability. So that's really how we might want to define a service level agreement on traffic that's being sent through the network on this particular service. Just to give a couple other examples from a service level agreement that have been defined in MEF 23. This is really looking at some different types of services that you might be looking at: mobile backhaul, the EPL or EVPL, voice trunking services. So you can see the bandwidth, examples from 1 meg to 10 gig, committed burst sizes ranging from in kilobytes, 64 to 256 kilobytes, frame delay of less than 10 milliseconds or less than 25 milliseconds, frame delay variation, frame loss, throughput availability, and mean time to repair. So again, this is just some example of service level agreements that have been defined by MEF in 23.1. So what are some of the things that can happen if we don't meet our service level agreement? And some of these KPIs. What are the problems that the user might experience if we're not doing the things that we're expecting? So from a latency perspective, if you're looking at voice traffic, you're going to see things like overtalk or echoes or drop calls if the latency is too high. It's going to take just longer for the voice traffic to traverse the network, and that's going to lead to weird sounding calls. On video, you might see choppiness and delays of being able to download, or especially if the latency jumps up during the middle of the call, you might overrun the buffers, and that's kind of where that choppiness and the green screen comes in. And for data, you can have long download times. Most of the data is going to be dealing with TCP transmits. So the longer the latency in the network, the worse your performance is going to get. And we're going to talk about that a little bit more in a future webinar when we talk about TCP testing. From a packet jitter, packet delay variation, on voice you're going to see clicking and popping noises as the codec attempts to deal with kind of the random or prolonged delay. The codecs can deal with a little bit of packet delay and delay variation, but when it gets too big, they start to break down. Same thing on video. You'll see pixelization or blue screens. Again, that happens when the codecs get delay variation that's outside their expected range. For data, there's really not much of an effect here. The actual impact of packet delay variation on data transmit is relatively small, because again, you're typically reassembling the file, and it's happening over much longer periods of time than the actual delay variation. So that's not really a problem for data traffic. What is a problem for data traffic is frame loss. That's really, for data traffic, that's really one of the killers. And again, as I said, we'll talk about TCP traffic a little bit more in the TCP protocol, but frame loss is really the enemy of TCP. So you're going to have very long download times with TCP traffic. In voice, if you have frame loss, you'll get clicks or fuzziness, or potentially even dropping the call if it gets too severe. And on video, you see the same kind of pixelization or blue screens that you would have seen that you would have seen with the delay variation. So what to do when things go wrong? This is just some examples of running some tests that we have had as a service organization contracted out with some service providers, and this was just our view of some of the things that could go wrong in a circuit that would cause service level agreements to not meet their expectations. The top one is auto negotiation settings being set incorrectly. The second one here is the 802 versus DICS framing. Third here is a misconfigured CIR, or committed information rate, just having that set wrong. And then the last big one here is just having the wrong VLAN. Either knowing what the right VLAN was to provision the network equipment, or potentially just even knowing what the right VLAN is to communicate to the customer of what VLAN they need to include on their traffic. So again, the biggest one here is auto negotiation problems, setting that up, but there are a variety of different issues that can contribute to failing the first test, which happened in our experience about 45% of the time. So before we jump into the 2544 and 1564, we just want to make sure we're talking about this in the context of a holistic context of testing these services. What we see a lot of customers doing, or service providers doing, is either not testing or testing with just a ping. And we really feel like that with the more thorough testing now, we can prevent a lot of the problem truck rolls later. So that includes talking about testing with RFC 2544 or YDOT 1564 to validate KPIs for Ethernet and IP layer traffic, testing layer 2 control plane transparency with JProof, and testing RFC 6349 true speed to validate TCP performance. So this is really a kind of a holistic set of tests that we're encouraging our customers to take advantage of, and with that, I'll turn it over to my colleague Barry to kind of talk about some of the key measurements in service activation testing and 1564 and 2544 protocols.
Okay, thanks, Mike. So yeah, what we're going to talk about now is some of the measurements, benefits, and specifically between 1564 and RFC 2544. So first we'll go into YDOT 1564 summary. The Viavi branding on that is SAM Complete, which is Service Activation Methodology Complete. Relatively newer industry standard, ratified in 2011-2012. The key word here when you think of 1564 is it was intended for multiple services Ethernet testing, which RFC 2544 was not. And another thing, some of the key performance indicators are listed here. We see CIR, which is obviously throughput. We'll go into that some more in a bit. Frame delay or latency, frame delay variation, which is the delay, the variation and the spacing of the packets, frame loss rate or FLR, committed burst size, and an actual policing test. So we're going to talk about each one of those in detail when we go through the demo. One thing I want to mention too, even though it was a multi-service test, I mean, as far as like its original intention, it's also very efficient to use as a single service test as well. So let's talk about the steps of Y.1564. 1564. It has two parts: the service configuration test, some people call it the ramp test, and you can see that it's going to be one service at a time. So if you had 3 services, you're going to take service 1, run the ramp test, service 2, service 3. So there's logic behind that, because if one of the tests fails this individually, then there's no sense in running the other test or running them all together, because you know you're having a problem with one of them. It runs it in steps, and you can see in the green portion of the ramp here, that's configurable. You can run them from 1 to 60 seconds each step, and during that time, all the SLA parameters of delay, jitter, and frame loss are measured and verified. And then what happens after you verify that the CIR is met, there's sometimes in an SLA there's a EIR and an MIR that's specified. The EIR generally is a best effort type of part of the SLA, so that's not guaranteed, but that could be measured. And then there's also many times providers going to police, and like let's say you had a gig network and you only bought 100 megabit traffic, then you want to verify that if you go, you can go over a certain extent to what's called the MIR, but then after that you will get dropped. So that's called the MIR. Okay, so I already talked about those bullets. So now after each test is run individually, the next part of WIDA 1564 is the service performance test. So this is where you get into the multi-services all running at the same time, and the key element you're trying to verify is QoS. And if you have like triple play in the diagram shown, you have a phone, you have a video on the bottom, and you have data. You're running all the tests all at the same time at the CIR for each. You're measuring the metrics of frame delay, delay variation, and frame loss, and you're also verifying that each of the services is getting the QoS that it was configured for, whether that's with VLAN, VLAN pbits, DSCP, and those types of things. You can run the test. You can do it over a short period of time. You could do it as a soak test, a long period of time. And so, again, it's really a test about, when you have RFC 2544, you're running one service at a time. This way you're running all three or all four, whatever, simultaneously, and just verifying that all of them will work as expected together. Okay, so now back in time a little much further, RFC 2544 summary, and on the right hand side is a diagram of our screen for our product. It's a widely used, probably the most widely used test still today, although that keeps changing. It was intended to be a lab test, and that would be to verify switches and routers and the performance of a device, and it was so popular in those type of test scenarios that it was adopted into the field and in operational networks for service activation. Single service test, again, mentioning that. And the key performance indicators and bandwidth profile, similar to 1564's throughput, latency, frame loss, packet jitter, committed burst size. Now those two, packet jitter and committed burst size, are part of VIAVI's enhanced RFC 2544. They are not part of the RFC 2544 standard. And again, the test runs, it's very wizard-like in nature, and you get a full report at the end of the test. So let's take a minute here and go through a table, row by row here. The columns are comparing RFC 2544 to WIDA 1564 just from a terminology standpoint, and what the measurement means. And so sometimes that causes a little bit of confusion, but in RFC 2544, when you're transmitting megabits a second traffic on the wire, that's called throughput, whereas 1564, that's committed information rate, or CIR. Those are the same thing. 2544, when you're measuring the round trip time or the one-way delay, that's called latency, and in 1564, it's been coined frame delay, or FD. When the test is running and frames are being dropped and they're being measured, that's called frame loss in RFC 2544. In 1564, the frame loss ratio. So that's the number of frames that were transmitted versus the number of frames that were dropped, or vice versa. So again, in the 2544, jitter and burst were not specified, but are part of the enhanced RFC 2544 provided by VIAVI. In 1564, jitter is frame delay variation, and again, that's the latency variation between packets. So it's not really the latency on the measuring round trip, but just looking at packet timing. And committed burst size, or burst, that's, if you have a gigabit service, a gigabit link, but you've only about 100 megabit worth of service, then that's how there's a parameter called CBS that specifies how many bytes you're allowed to burst at the gigabit rate without losing any packets. In the RFC 2544 column, there's no policing test, but in 1564 there is a policing test, and what that does is it verifies that a policer is set properly, so that, again, if you had 100 meg service and maybe a 20 megabit allowance above 100 megabits before a policer kicks in, you want to verify end to end that the policing value is set properly, so that the customers only get what they paid for. Okay, so I'm going to go through now some testing scenarios and a demo of 1564. For the scenario, I just want to talk a little bit about, a logical Ethernet business topology. And in this diagram, you see on the left and the right customer equipment. Those could be a branch office and the headquarters. Sorry about that. That could be the branch office and headquarters. That could be branch office going to the data center. It could be different variations of that. But the important part about this is there's a network and it's got different levels of demarcation. That could be the end customer to the carrier, or it could be carrier to carrier, but there are different portions of the network that need to be tested and verified. And also you can see in the diagram, you see on each end we have, this is depicting a Viavi instrument, so that's a hardware device. You can also have devices inline. We're showing some of those, like probe-like devices. And these functions can also be virtualized. In other words, they could be software components either on the end equipment or like an end host, or it can be part of the network itself. And we have solutions for that as well. Okay, so with the first demo, what we're going to do is we have a T-Bird on the left, which is we call the local T-Bird, and on the right-hand side, the remote T-Bird 5800. We've got a network comprised of Cisco 3400 Metro Ethernet gear switches, and you'll see at the top that we have 100 megabits per second CIR and a 64 kilobyte committed burst size. So that means on this gigabit network that the end customer purchased 100 megabits CIR and then also a 64 kilobyte CBS. So they're allowed to go up to 100 megabits, but not much more. And the round trip time is 40 milliseconds in this scenario. So I'm going to flip over to the demo. And what you're going to see here, this is the local T-Bird. And we have a quick select guide, launch point. So we're going to do a layer 3 test. So this is going to be an IP layer, SAM complete, which is our branded name for Y.1564. So it's just going to take a moment to load. And the other side has an IP address, so that's the one requirement. Obviously, it's a layer 3 test, so the units have to be able to talk to each other across the routed network. Okay, so what we're going to do here is we're going to load a configuration. We allow the user to save configurations, set up complex test scenarios, and we'll just load that right up. And there we go. Now we're going to go ahead. I want to show you a couple things before we jump into the test. What we have for the test today, it's going to be a loopback. We have the local T-Bird, which is going to loop back the far end, but there are different modes of operation. You can also do asymmetric, unidirectional, or you can do downstream and upstream. So if I click on downstream and upstream, you'll see the graphic change, and now we have 2 T-Birds, and you could be running the test concurrently in each direction. For this test, to keep things simple, we're going to loop back the remote T-Bird. So it's got a nice wizard-like user interface. We're only going to do one service today to keep things, relatively short, and frame sizes can be configurable for each service. Right here this is just the basic settings for the two T-birds to speak to each other. This T-bird is 192, 168, 1.10 talking to a 1.3. You can ping the remote T-bird just to verify, that you have basic connectivity. Now here's some important settings. The CIR again is 100 megabits per second. This particular emulated SLA, there's no EIR, but there's an M value, and what that means is that the customer will be policed if the traffic exceeds 120 megabits per second. So this will be verified that that'll happen. We're not going to perform burst testing, but that's an option in both 1564 and RFC 2544 test. Now we have the metrics, the frame loss ratio, frame delay, and delay variation. Here we've set the frame loss ratio to 0, so 0 packets will be lost or a failure will be declared. Frame delay, we have a 40 millisecond round trip, so we made this 50. And delay variation, we allowed that 200 microseconds. Okay, so there's some choices here as far as like the service configuration portion, which is step 1, how many steps you'd like to take, how long each step you'd like to run. And then as far as the service performance, again, this could be a quick test or it could be a long test. There's lots of options there, all the way up to user defined. Now we could save the profile, but we've already done that. Now we're going to go to run the test, and we're going to select both tests to run. And one of the options you have, which is kind of nice, is a stop on failure. So at any point along the way, either of these test fails, you don't have to wait to the very end to figure out where it failed. I'm going to now go ahead and start the test. And you can see it's running here. It's basically just setting up the remote side. You can see little icons here that saying that it's looping back the remote end. It's doing the service configuration test first, which is again is the ramp test, we call it. And the graphic shows you can watch it as it runs. What we've done is we've optimized this where we don't start at the bottom, we start at the top, because this saves time. In other words, it's going to test at 100 megabits per second, which you can see it's doing right now. And it's also giving you the real-time, this is the thresholds, and it's giving you the real-time data, what's happening on the wire. Notice the frame delay is 40 milliseconds, just like we talked about in the demo diagram. Now let's look at this policer test. The policer test is running, and we're going all the way up to 117 megabits per second. Now we're starting to drop. So that's actually, it's a little bit non-intuitive at first, but that's a pass, because if the policer wasn't set properly, that traffic would have actually made it through, and then you'd want to know about that because your policer wasn't set up properly. So let's go back to service configuration. We got a check mark there. That's good to go. Now we're running the service performance test, and this is running. It's checking these 3 metrics all at the same time on our single service. Anytime along the way, you can go in and take a look at what's happening. So right now on service 1, which is our only service, we're getting 0 frames lost. Delay, we should be getting about 40 milliseconds round trip, which we are. And then we can also look at the delay variation, which should be very low. Okay, but our threshold, you can see it's kind of nice. You can see the current value, the max that was ever seen, the average, and always the threshold that it's looking at. So Mike, while this is running, is there anything else you'd like to add? Or
I think that's a good summary, Barry. I think the this screen here is showing just the high level, so you don't even necessarily need to dive into the details. But if you choose to, you can certainly look down at exactly what's happening on each of the individual tests.
Okay, so that's that. A report can be generated, PDF. It could be taken to USB stick or emailed. And so now we're going to go back to the main presentation. And okay, so that was our demo that we did. So Mike's going to talk about also there's some tests that sometimes when you don't want to do a formal test, you want something very quick. So I'm going to turn it back over to Mike, and he's going to talk about non-SLA services.
Yeah, so for non-SLA services, in general, what we've been talking about so far with 1564 and what a lot of people have been using RFC 2544 for is testing the services that have a service level agreement attached to them, so customer-facing services with the service level agreement. But there are a lot of scenarios that network technicians and engineers have to deal with where they don't necessarily have a service level agreement, and so they can deal with a simpler test. So some examples of that would be internal network connections, such as transport network circuits, or potentially that could potentially be running up to 100 gig as an example. Installation of network equipment or replacement of line cards, scenarios where you might want to be able to just test through the one particular node, one line card to the other line card, to make sure that things are working the way that you're expecting them to be working. Or scenarios that are actually customer facing but are maybe delivered as a best effort internet access service. Examples of this could be things like using residential quality services like DSL or cable DOCSIS, or maybe some of the various different kinds of PON, and offering a business service over that. Oftentimes, you're not going to want to provide a Metro Ethernet forum type service level agreement, but on those types of services. But you may want to be able to test just to get a sense of how well things are working. So again, in these kinds of scenarios, a simpler test is often the right solution. And so what we've developed is a test that's called Quick Check. So this can be used in two different applications. First of all, it can be used as a pre-test in RFC 2544 or YDOT 1564. The scenarios where you're just trying to first of all qualify the circuit to give a sense of if the longer 2544 or 1564 even has a chance to pass. You can think about this as automating some of the methods and procedures around just getting basic connectivity tested and in place. Or the other alternative for using Quick Check is as a standalone test for non-SLA services like we talked about before, either the best effort internet access, internal links, or the maybe testing network equipment. So what this test does is it checks near-end connectivity and auto negotiation, as you can see in the graphic here. So we're just making sure that we've auto negotiated appropriately. It's checking connectivity to the far end. So first of all, just can we connect to the far end? And then we try to identify what type of loopback we may have, whether it's another test set or test equipment, whether it's a permanent loop or whether it's a hard loop. And then it'll do a measurement for throughput and frame loss. So not all of the different KPIs that we had in 1564 or 2544, but a couple that might be important just to get a sense of how this particular circuit is working. So with that, let me just jump back to Barry, and he can set up the second demo that we're going to be doing with a similar network.
Okay, hold on 1 second. And what we're going to do is just have to get out of the 1564. And then we're going to go ahead and pick the standalone Quick Check traffic test. So that'll it's the same setup as we had before, only now we have a gig network between the two. And it's very easy to run. You can see that, basically it has a start button. There are some advanced options that we can go into. And I can see here that someone had set this up for a 100 meg, but we have a gig circuit, so we can just change that very quickly. You can change the duration. We can just make that 30 seconds just to run the test pretty quickly. And then, off we go.
So already we've identified that the local port is up. So we've connected to our local port. We've identified that we can ARP to our gateway appropriately, and then we've quickly identified the remote loop we found that it was the far end instrument that we were testing against. If we hadn't found the far end instrument, we might have found that we were in a permanent loopback scenario, which you might see if you were testing over a dark fiber or through a network equipment, or in loopback, or possibly over an OTN network. And then we could also find that we were testing to a permanent loop. So now what we've done over the last 30 seconds of this test is identified that we got just about a gig of throughput and no lost traffic. So that's the quick check in a nutshell.
Yeah, so it's just that easy to run, and it could be a good bridge for folks that don't want to run a formal test but are doing pings right now today. So let me go back to the slide deck here, and I'll let Mike wrap it up.
Yep, thanks, Barry. So from a from the testing methodologies perspective, we've talked about the RFC 2544 and 1564. We showed you a demo of that, and then we just showed you the demo of kind of the quick check, which is both in 1564 as well as 2544 as a pretest to see how well things might be working. So what we have here for you is just our contact information, and all of the different webinars that we're doing. This one today, the one that we'll do in a couple weeks, and then the following one are also summarized in a series of white papers that talk about some of the same topics that we're talking about today, and go into a little bit more detail on some of the different types of tests, the methodologies, and you can use those as reference for actually understanding how some of these tests work a little bit better. So thank you for joining us on this webinar, and hope to see you on the next one.
Thanks, everyone. We'll close up now. We'll be in touch with more materials, and you can always find the webinars listed on the P&V homepage under the tab Webinars. Thanks again for attending.